Let's move into section 8.4, doing a hypothesis test for a population variance. If I wanted to do a test for a population standard deviation, what's the relationship between variance and standard deviation? If I know what the variance is, how would I get the standard deviation?
Square root.
No! Square root. You said square.
I said square root.
All right. We're gonna have to go to the replay on that one. So as before, you have the observations come from a simple random sample. And unlike our previous problems where we said that the sample size had to be greater than 30 or comes from a normal population, that kind of thing, our assumptions there were a little bit lax. Here it's actually a very important assumption that you have data that's normally distributed. If your data aren't normally distributed, don't bother to do this hypothesis test. It will give you flawed results. So how do you check whether or not something has a normal distribution? What could you do? Yeah. Graph it. What else? Normal quantile plot or more than one outlier probably means that it's not normally distributed. Now, either the problem is going to state this, or you're going to have to test it. You check it. So there's 3 different ways you could check it. If the data has more than one outlier, it's probably not normally distributed. You can look at the histogram, or you can look at a normal quantile plot. Now, a lot of this is going to start to fall into a nice little pattern, and I've deliberately set things up that way to get you kind of in a little bit of a groove. State your null and alternative hypothesis. Of course, your null hypothesis has to have either a less than or equal to, or greater than or equal to, have to be part of your null. Decide on the level of significance alpha. That's either going to be given to you, or you're just going to assume that it's 0.05. But you're probably not going to have to worry about deciding on alpha. Step 3. If you're doing the p-value approach, which is what we're doing in this class, you can kind of skip this step in terms of finding your critical values from the chi-square distribution. And it's going to be replaced by input the data. Input data into StatDisk, or whatever statistical problem software you're using. Step 4, compute the test statistic or find the p-value. Okay, we're going to be finding the p-value in this class. If the p-value is low, H0 must go. So finally, state your conclusion in words using the conclusion or your wording the hypothesis guide that we've given out. So there we go. Those are our steps. It should, like I said, start to fall in a little bit of a pattern. Let's actually do a few problems. Now, the one that I really like is it's one that came out after 9/11. I think most of you were too young to even be alive during 9/11, but right after 9/11 there wasn't too much happening in the skies. They didn't let any planes fly for several days, and what that meant was that you didn't have all these contrails from airplanes spreading out in the skies. Now those contrails change the temperature variation because they act as a blanket, keeping some of our heat and light on the surface of the Earth. They also act as a blanket to keep things from happening above, from influencing what's happening below. So it kind of changes the spread of temperatures that you get during the day. So what do we have that measures how spread out things are?
Standard deviation.
Our standard deviation. So it's a natural test of the standard deviation of daily temperatures. And the first paper I saw in regard to this said, yeah, hey, there's a difference in what's called, I think, the diurnal temperature range of daily temperatures during that 3-day period in which there was no commercial aircraft flying. So that was kind of interesting. And you're just doing the same kind of hypothesis test here that we're going to be doing in a minute. I then saw a competing paper that came out and said, you know what? Yeah, there is an impact here, or there is a significant change in the daily temperature distribution and its variation, but it's really more due to overall weather patterns and not so much the contrails. Hard for me to decide which one of these is right, but in either case, you're doing a test of a hypothesis regarding population variance, how spread out your data is. Now, our tests that we're going to actually do in this class are going to be a little bit more mundane, not as cool as something like that. Let's take a look at something that you would see in your homework. And in your homework, you're going to be asked to kind of fiddle with some of these little knobs a little bit. So you're going to have to decide, you know, your null and alternative hypothesis and put those in. Let's first of all look through this example. The piston diameter of a certain hand pump is 0.7 inches. The manager determines that the diameters are normally distributed with a mean of 0.07 inches and a standard deviation of 0.03 inches. So that's the current standard. After calibrating the machine, the manager selects 23 pistons and determines that the standard deviation is 0.0022 inches. So let's see. Randomly select 23 pistons. Now the important thing to realize is that this is your sample. That's your sample. That's your sample data. It's your sample. Now, what do they tell us in the sample? Well, one of the things they tell us in the sample is S equals 0.0022. That's your sample standard deviation. Is there significant evidence for the manager to conclude that the standard deviation has decreased at the 0.10 significance level? So, all right, there's your significance level. So that's alpha is 0.10. But decreased from what? What is it decreased from? Does anyone know? Yeah, from 0.003. So it has decreased from 0.003. So let's see if we can write that in terms of symbols. Now, when you're setting up your null and alternative hypothesis, you should always have stuff that has symbols in it. Symbols that relate to population parameters. So those population parameters are going to be mu, sigma, and p, depending on if you're working with a mean, a standard deviation, or a population proportion. But it should be one of these. This is the only thing that should go in your null and alternative hypothesis, is these symbols. If you want to lose some quick points, put in a statistical or a sample statistic instead of a population parameter. So what's that going to look like here? Sigma. Yep, sigma is less than 0.003. So you got to decide now, is that going to be part of your null or alternative hypothesis? Where is that going to go? Yeah, it's going to be the alternative hypothesis. It has to be the alternative hypothesis. It doesn't contain the possibility of equality. So we've got HO and HA. Let's put this in HA first. Sigma is less than 0.003. And then HO. Yep, sigma is greater than or equal to 0.003. Now keep in mind, when you do this in your homework, like right here, what are you going to end up putting there? Yeah, you're going to put in equals. So sigma equals 0.003. That's for my stat lab. On the test, I'm happy with either one. Doesn't matter. So you put those things in here. Let's see, the null hypothesis and the alternative hypothesis. So you use those dials to dial those in. Well, let's see. What else can we do here? Well, we can calculate a p-value for ourselves. Come up with this. Now, I don't know as though it's going to necessarily match this or not. I think it might. But every time you do these types of problems, you do it at home, I do it in my office, etc., it auto-generates different data. So sometimes we get some different type of values, but I think we'll be okay finishing this up. Let's go to StatDisk. Let's see. There's one other thing that we're going to need here, and that is this number right here. That's n is 23. If n is 23, anyone want to wildly guess what our degrees of freedom is going to be? 22. Good. Degrees of freedom equals 22. Now, you're really only going to need degrees of freedom when you're trying to calculate a confidence interval. If you're trying to calculate a hypothesis test, it's going to ask you for n. Don't input the degrees of freedom if it's asking for your sample size. Let me open up StatDisk. Where should I go? Analysis. Hypothesis testing. Standard deviation 1 sample. Do we have data or summary statistics? Do we have a set of data? No. So let's see. Our alternative hypothesis. Where am I at here? Neat. What form of my alternative hypothesis should I choose? 1, 2, or 3 here from this menu? Let me look back at this for you. So here is your null and alternative hypothesis. So take a quick look at that and let's decide, well, which one do we want? We want 1, 2, or 3 as for my alternative hypothesis. Yeah, 3. Our population standard deviation is less than some claimed standard deviation, and that claimed standard deviation, anyone? 0.003. That claimed standard deviation comes from your null hypothesis. This is what we're assuming is true. That's how these things start, is you're assuming that that's true. So that's where your claimed null hypothesis comes from. Sample size. Remember, it's asking for sample size, not degrees of freedom. So sample size would be 23. How about the sample standard deviation? 0.0022. Yeah, I guess it's 0.10, right? It actually won't affect our, let's see. Yeah, I guess it'll affect the p-value. No, actually, no, it won't. We're still okay. All right, so let's think here. I think we got all we need. So use technology to determine the p-value for the test statistic. Our p-value in this case is what? 0.039. All right, so 0.039. So looking good there. What is the correct conclusion at the 1% significance level? So let's think about our conclusion for a second. And let's see. Q, I don't think I've called on you yet today. I did? Nice of you to remember. Can I call on you again? All right, Sam. What do you think we're going to conclude? There's our p-value. And alpha, alpha is 0.10. So what are we going to do? Are we going to reject H naught or fail to reject H naught?
Since the p-value is less than alpha, we will reject it.
Yeah, perfect. So step 5, p is less than alpha.
We will reject HF.
Therefore, yep, perfect. Reject H naught. Nice. So we're rejecting H naught. Now, would that conclusion change if we were working at the 0.01 significance level? Yeah, because it's at that point p is greater than alpha, so it would change. So what's the conclusion at the 0.01 significance level? Since the p-value is 0.039, then the level of significance is. Let's see, what would they be asking for here? The level of significance is. Yeah, you're going to fail to reject. So fail to reject here. Fail to reject H naught. Then there is not sufficient evidence to conclude that the standard deviation has decreased at the 0.01 level. There is at the 0.10 level, there's not at the 0.01 level. So if it's really important that you don't make a type 1 error and use a small value of alpha, then you're going to not reject, you're going to fail to reject, and you can't conclude that there's evidence of a change. So even though it might look like it's gotten better, we can't conclude that. Yes?
Why do we fail to reject H naught if the p-value was less than alpha?
So the p-value is less than the alpha stated up here, but then there's a kind of a part 2 to this problem that starts right here. And that is, well, if we changed our level of significance to 0.01, now what's the conclusion?
Okay.
So we've got a new level of significance, so that changes our conclusion. Yeah, you're right. In the first case, we correctly rejected it. In the second part, we failed to reject.
Thank you.
No worries. Good question. Now for this next part, let me remind you of something that goes back a little ways. It's really putting a little bit more into a problem that I particularly care for. It's going to go back to the empirical rule. So bonus points if you can spell empirical correctly. So here's our normal distribution. And you might remember that, you know, within 2 standard deviations away from the mean, you get about 95% of your data. Now let's take a look at that 2 standard deviations away from the mean. So that spread of 2 standard deviations away from the mean is a good guide to your range. So you've got your mean, so your x bar plus sigma, or s, and x bar plus 2s, x bar minus s, and x bar minus 2s. So that distance there, that total distance, is about 4 standard deviations. So now, if this is the top of my data, and this is the bottom of the data, then does anyone remember what we called the top minus the bottom? Yeah, that's the range. And that range is about 4 times s. You've got 4 standard deviations strewn off across here. You've got 1 here, 1 here, 1 here. So you get a total of about 4s. So you get this approximation that the range is about 4 times s. How would I solve for s here? Yeah, divide by 4. So the range divided by 4, it's a cheap way to get an approximation to your standard deviation, is to divide the range by 4. And they're using that in this problem, and I'm happy to put this as part of the notes so that, you know, if you see this at home, you're not going to panic. It is putting a little bit much into one problem, though. Makes the wording a little bit more difficult. A simple random sample of 35 men is normally distributed, results in a standard deviation of 12.12 beats per minute. That's going to be heart rate. So let's keep track of a couple things. Is that 12.12? Is that my population parameter or is that my sample statistic? Thank you. Sample statistic. So that's S. S is 12.12. And we also know that we have 35 men. So that's N equals 35. So we're just keeping track of a couple things here. The normal range of adults is typically given between 60 and 100 beats per minute. So if you apply the range rule of thumb to that, it'd be 100 minus 60 is 40, divided by 4. 40 divided by 4 is 10. So that's where they're getting the 10 from, which, you know, like I said, it's adding a little bit more complexity to this that I want. But the 10 beats per minute, that's your sigma. Use the results with a 0.1% significance level to test the claim that the pulse rates of men have a standard deviation equal to 10 beats per minute. So there's your original claim right there. Let's, you know, I like doing the original claim in orange. Sometimes I joke that it's the orange claim. Men have a standard deviation pulse rates of 10 beats per minute. So there's your original claim. What's that going to be in terms of some symbols here? What would that be? Ooh, not S equals 10. Sigma equals 10. Good. Make sure you keep statistics out of there, parameters in there. So if that's S equals 10, then let's think about our null and alternative hypothesis. I'll give you a few seconds to try and write that down for yourself. Try and figure out which one of these looks good.
I have a question.
Yes.
I'm a bit confused why 12.2 is a sample standard deviation, because in the verbiage
Says
it said.
a simple random sample right there.
Okay,
So
but then that's
this is coming from, this pertains to the sample.
Okay.
It's not to the population. The next part of it, like I said, it's a little awkward because they say, well, let's use the range rule of thumb to come up with an approximation for the standard deviation, and that results in a standard deviation of 10. And then they say, all right, well, let's test the hypothesis based on the 10. It's not my favorite problem, but I think there's one like it in the homework, so I just want you to be aware of that.
Well, thank you.
Mm-hmm. All right, so which one of these looks like a winner? If this is sigma equals 10, is that going to go in the null or alternative hypothesis? The null. Nate, have I called on you today? Yeah, but you're going to... All right. All right, so tell you what. HO and HA, what are they for this one?
So that'd be sigma is equal to 10 for HO.
Good.
HA is going to be sigma is not equal to 10.
Perfect. Perfect. Thank you.
1 for 2.
All right. Hey, that's a good batting average. You'd be in the Hall of Fame with that batting average, right?
Put in there and judge.
Yeah. All right. So I think that's this one over here, right? That's this one. All right. So there you go. Now, let's compute our test statistic. So to compute our test statistic and finish off this null hypothesis test, that's step 1. Step 2 is alpha is 0.10. Step 3, we need to input our data, and that's going to include two things. It's going to be n equals 35 and s equals, where is it, 12.2. And we'll get a p-value when we input that into StatDisk. So let's do that. Let's see. We're going to be doing summary statistics. You have to change your alternative hypothesis. Our significance level is okay. Our claimed standard deviation, what's going to go in there? Yeah, I like Cosmos. This many. Holding up both hands with his fingers stretched out. Well done. So 10. N was 35. Sample standard deviation. Someone else for sample standard deviation. Edmund. I don't think I picked on you yet today. 12.2. Perfect. So there we go. So our test statistic is 50.65. I don't think we really need that. What's the information I really need from this part of our p-value? Sabrina, what's our p-value?
0.06.
Good, 0.06. So 0.06. So if our p-value is 0.066, what's our decision? Nicholas, what do you think? What are we going to do here?
P-value is less than alpha.
Yeah. So 0.066 is less than 0.100. This is less than this. Therefore, reject H naught. Good job. So our original claim is right here. It's part of our null hypothesis. Let me circle that. That's our original claim. Let's see about wording our conclusion based on our original claim. So let me go back here and find wording the conclusion. That would be this one. Does the original claim contain the condition of equality?
Yes.
Yes, it does. Did we reject?
Yes.
It didn't seem uniform on that. Yeah, we did reject. So there is sufficient evidence to warrant rejection of the claim that the standard deviation of healthy male heart rates is 10. All right, so let's write that down. There is sufficient evidence to reject the claim that the standard deviation of healthy male heart rates I'm just going to abbreviate HRs, is equal to 10 ppm. Awesome. Awesome. Notice that I don't have any parameters here. There's nothing about sigma. There's no symbols like equals or less than symbols. It's all just written out in words that relate back to the problem. So please, this is exactly the way I expect it. I will give you the wording, the conclusion hypothesis, or wording the conclusion sheet for you to use on the exam. Just make sure that you don't have anything else on it. And then you can continue to use it. Any other follow-up questions here? Yes, Ian.
Next Tuesday, right?
Week from Tuesday, yes. Week from today.